Now, now we want all these residuals to occur simultaneously at once. Okay, this from the law of probability, the probability of simultaneous occurrence of these residuals can be given by the product of the probabilities of occurrence of each individual residuals. Okay, like this, by the multiplication of each probabilities. Okay, then the probability becomes like this. So on for this is P1, this is P2, so on for Pm. Okay, now we can simplify this to this equation. Okay, there are n k's, so k has been raised to power n. Okay, and there are n delta v's, so delta v, there are also this is also raised to power n. Okay, similarly, this exponential values from the law of this exponential multiplication, we create this. What we need is that this probability should be maximum. Okay, these things are constant for this equation. Okay, now we need this probability to be maximum. For this probability to be maximum, the value of this function should be also be maximum. Okay, okay, let's see how this term, this exponential term, behaves to behaves or contributes to this probability. First of all, let's see how does a function e to the power negative power, or say e to the power negative x behaves. This is the plot of e raised to the power e negative x. From this graph, we can see that whenever the value of x decreases, there is an increase in the function's value like this. That means for a function e raised to the negative power x, the function's value increases whenever the value for x decreases. So from here, we can say that for p to the maximum, this value should be a minimum. Okay, okay. That means for the most probable value, the value of this term over here, the square of this residual should be a minimum. Okay, then we can substitute these residuals with m and g. We get it like this. Okay, then now we have to okay, have some idea on this maximum and minimum values of functions. Okay, I'm not going to that part in detail, but let me tell you that for a function to be minimum at any point, okay, the first derivative of this function should be equal to 0. It should be equalized to 0. Okay, now if we want this equation to have a minimum or maximum at point m for the value of m, then this equation should be equated to 0 for its first derivative. Okay, this can be minimum or maximum when the first derivative is equals to 0. Okay, then let's say, okay, let's find out what should be the value of m when the value of function is minimum or maximum.